we are starting our solving absolute value equations lessons. We're going to solve absolute value equations today. We will also solve absolute value inequalities eventually. This is a 2-day lesson, which is why you saw the day 1 screen. We're going to do this first foldable today. We will do the second one tomorrow, just so that we kind of space it out a little bit. Number 1 and 2 talk about solving absolute value equations by graphing. You are used to graphing them. We have done that before. It's been a little while, so this might be a little bit of a refresher. But to solve absolute value equations by graphing, we're actually going to graph the left side first. We don't even care about this part. And to do that, we actually need the vertex. So the vertex of that piece, if you remember, the vertex form is x minus h, where h is the x value, so 3. The formula says minus, so it's positive 3. And then it's plus k, so this is 3, 2. I'm going to put a point there at 3, 2. There is no number in front of the absolute value symbol, which means that it is a 1 for a. So we just are going to graph up 1 over 1 until we run out of room. Remember, it's a good idea, especially since we're solving now, to go ahead and cover the entire graph. Arrows, because it goes on forever. Alright, we're going to graph the second piece. It's also been a while since we've done this. This is like, not x, y equals 5. We've got an x right there, it's not x equals. Y equals 5. If you remember, we've got a slope of 0 and a y-intercept of 5. So I start at 5, and it's just a horizontal line across. We have completed systems of equations already, so you know that when you have two lines drawn, that my answers are wherever the two cross. So my answers are x equals 0 and x equals 6. So we have two answers to this equation. So we the answer to this equation. We are going to do the same on number 2. You need to take a minute and work on it yourself, so pause the video if you're working on this. Okay. We are, just like before, going to find the vertex. And the vertex for this, -4, because this is positive. The actual equation is minus, so two negatives made it +4. And -1 from this value. So -4, -1. Again, there's nothing in front, so it's an up 1 over 1, kind of like slope there. That's how A acts. A acts like slope. So we have covered the entire graph again. It's always a good idea to do that. And likewise, we have this 3 over here. It's the same as y equals 3. So we're going to go to 3. We've got a point that meets already right there. We're going to draw a horizontal line. And I've got my two solutions again. When x is -8 and when x is 0. So I've got two solutions for each of these. While that's a review of graphing absolute value equations, there's also a way to do it algebraically. We've got a couple more examples, so if you open up, but first of all, we're going to write the steps to do this. It'll be easier if we have steps for solving our absolute value equations. So step 1 for solving absolute value equations is to isolate the absolute value. So step 1, isolate the absolute value. What that means is get it meaning these bars by itself. That's what that means. So step 1, you're going to get the bars by themselves. You'll still have stuff inside these bars. That's okay. Step 2, we will then create two cases, or like two equations. We will have a positive one. Let's put negative over here. We'll have a negative one and a positive one. The reason that is because you have an absolute value. The absolute value of negative 3 is 3, and the absolute value of positive 3 is 3, which is why we have to have negative or positive, because it could be negative in here and come out as the right answer, or it could be positive in here and come out as the right answer. And we will then solve each equation. So there are 3 steps. We're going to go ahead and work with number 3 over here on the right to get those. I'll leave that there for a second in case you need it. You can also pause the video if you didn't get it written, or if you need to come back and look at this. These are our 3 steps that we will go through every time. Number 3. Step 1. Isolate the absolute value. Here's my absolute value symbol. I don't care about the stuff inside at the moment. I care about what's right here. I need to move this away from the absolute value. To do that, I need to do the opposite. So it's currently negative 9, so I'm going to add 9. It's going to go away on the left side, and I'm left with the absolute value of x minus 10 is equal to 8 plus 9, and 8 plus 9 is 17. Step 1 is isolate the absolute value. The symbol, the absolute value, is by itself now. The only thing that's here is stuff inside. So step 2 is to create two cases. What that means is I'm going to write this down, x minus 10, without the bars, the absolute value bars, and equal it to a negative 17. I'm going to do the same thing, but this time I'm going to write it as a positive 17. These are the two cases. The number is the piece that is negative. I'm now going to solve both. So add 10, goes away. So x equals negative 7. It's one of the answers. Add 10, goes away. X equals 27. I have two answers, but they are both possibilities for that equation. Let's look at number 4. All of these are the same process. If you're working on this by yourself, it's good to pause this video and work number 4 yourself. We have to isolate the absolute value. Here's the absolute value. We have to move this 9 over. It is again a negative 9 or minus 9. It's the same. So we have the absolute value of 6r equals 18. That's step 1. Again, step 2, create two cases. 6r equals negative 18. 6r equals positive 18. Step 3, solve them. Divide by 6. Divide by 6. R equals negative 3. That's one answer. Divide by 6. And divide by 6. R equals 3. There are my two answers. It just so happened that these come out as positive and negative 3. It doesn't always work like that, as you saw in example number 3. Make sure you pay attention to that. Don't get in the habit of just saying, oh, well, they both have to be the same number, just one's positive, one's negative. That's not always true. Again, if you're watching this to learn this, you need to do number 5 before you continue with the video. So pause it if you need to. Step 1, get the absolute value by itself. So subtract 3. Absolute value of 5p plus 1 is equal to 9. The absolute value bars are by themselves, so two cases. One where 5p plus 1 is equal to a negative 9, and the other where 5p plus 1 is equal to a positive 9. Again, we're going to solve the equations. Subtract 1 because that's the opposite of plus 1. So 5p equals negative 10. divide by 5. P equals negative 2. That is one of the answers. Again, subtract 1. 5p equals 8. Divide by 5. And p equals 8 over 5. Go ahead and leave it as that improper fraction. Fractions are okay. Leave it just like that. At this point, we would normally stop before going on to the next one. So this would end day 1. We're going to go ahead and begin the second day in just a minute. Alright. The second day of these, we're still doing the same thing. It's still the same process. They're just going to be a little bit different. So number 6, we have absolute value bars. We've got 2a plus 5 inside of those. And we have this negative 2 on the outside. That is what we have to get rid of. In order to get rid of it, we are going to have to do the opposite. You need to remember that when there's a number right next to something, there's a multiplication symbol that's not visible, but it does exist. So we are actually doing the opposite of multiplication, which is dividing by negative 2. So 2a plus 5 is equal to 11. Again, like yesterday, we have to create two cases because we now have our absolute value by itself. So a negative 11 and a positive 11. Subtract 5. 2a equals negative 16. A equals negative 8 is one of our answers. Subtract 5. 2a equals 6. Divided by 2. A equals 3. Here are my two solutions. Go ahead and start number 7. Pause the video if you need to. All over again, I got to get the absolute value by themselves. So I'm going to subtract 2, as that's the opposite. Absolute value of negative 6 minus 2n equals negative 18. And I have a problem. Here's my problem. It is not possible for an absolute value to equal a negative number. There's no number that the absolute value of is negative. We did have a negative here, but when we got to the absolute value by itself, we had a positive. So this one was fine. This one is not, because when I have the absolute value by itself, it equals negative, which is not possible. Since it is not possible, my answer is no solution. I know it is a no solution because an absolute value by itself cannot equal a negative number. So if you see that, after you get the absolute value by itself, you cannot continue. You need to write no solution. So it's possible to have two solutions. It's possible to have no solutions. Let's see what else may or may not be possible. If you remember relating this back to systems of equations, we could have 2, we could have 1, we could have no. There might be a chance that we have 1. We'll have to see if we work through this. So opening this up to number 8. This one's a little bit more going on. I've got a negative 6 minus 9. The biggest mistake that students make, and you may or may not make this, is doing negative 6 minus 9 and writing down negative 15. This is not negative 15 because you have negative 9 times this absolute value. You cannot add these together or combine them, so do not combine them. We are going to deal with this negative 6 first by adding it to the other side. We're going to bring down the negative 9 and the absolute value bars. It's a good idea to make them longer because you don't want to mistake them for ones. And that equals 0. I still have something with the absolute value bars. Remember I said this is multiplication, so I'm going to undo this by dividing. The absolute value of p minus 8 equals 0. We have finished step 1. We are ready for step 2, which is to create two cases, a positive and a negative. Well, I have a 0. Negative 0 is not a thing. 0 is a neutral number, which means it is neither positive or negative. So I can't create two cases if I have a 0 here. I have to create one case and solve this equation. Which means there is only one possible answer for this question. So we could have two answers, we could have no answers, or we could have one answer. Two solutions, one solution, no solutions. Let's work with number 9. Number 9, I have to get the absolute value by itself. I'm going to move over the minus 4. I know that's the one I want to move over because I always need to move anything that is added or subtracted before I move division or multiplication. Alright, I'm now going to divide by 9. So the absolute value of v plus 10 equals 2. Okay. And I've got two cases. So this one came out like the other ones we have seen. Nothing special about this one. And I'm going to subtract 10 to finish solving these. Now, don't get freaked out because you get negatives. Remember, that's okay because when I plug it back in, the absolute values can change it so that it's not a negative at the end answer. So make sure it's all right to have a negative as the answer, just not when the absolute value bar is by itself. So I do have two. They are both negative in this situation. Just so you know, remember you can always go and plug these back in to make sure they work. So negative 12 plus 10 is negative 2. The absolute value of negative 2 is 2. 9 times 2 is 18. Minus 4 is 14. So it's a good idea to be able to plug these back in and make sure they work. Last problem that we're going to do for these is number 10. Number 10, again, I've got that situation where I told you this does not mean I have negative 3 plus 10. This 10 is multiplied, so I cannot add those two together. So I'm going to move this 3 first by adding it. I'm adding it because it has a negative, not because this is positive or anything like that. We're not looking at that symbol. So 10, absolute value of 6 minus 2x equals 60. And we're going to divide by 10 to get the absolute value by itself. So the absolute value of 6 minus 2x equals 6. Ready for the two cases. 6 minus 2x equals negative 6. And 6 minus 2x equals positive 6. I will then solve each. I'm subtracting 6, not adding it. I don't look at this symbol. I'm looking at the symbol in front of the 6. That's a common mistake, is to use this symbol when I need the one in front of the 6. So negative 2x equals negative 12, so divide by negative 2. X equals positive 6. Again, to check, you can go plug it back in for x, see if it works out. Alright, again, subtract 6. Remember, these are actually the same process. I just will get a different solution because this is a positive instead of a negative. So negative 2x equals 0. And then x equals 0. So here are my two solutions. Just a recap of some key points you should know from absolute value equations. How many solutions does an absolute value equation have? It can have no solution. It can have one solution, and more than likely, as we have seen a lot, it can have two solutions. How do you know how many the equation is going to have? When the absolute value is by itself, we know there is no solution if there is a negative number. To make sure you can see that, you cannot. Zoom out just a little bit. We know it is one solution if the number is 0. And we know there are two solutions if there is a positive number. This is a good reminder so that you do not do extra work and solve for something that is not